Hi everyone, welcome back to Math Together Canada. In this final part, Kaylin will be tackling questions 20 to 25 of the AMC 10B from 2024, the toughest problems of the contest. Let's finish strong with her walkthrough.
Okay, let's move on to question 20. So 3 different pairs of shoes are placed in a row so that no left one is next to a right one from a different pair. In how many ways can these 6 shoes be lined up? So we can let the 3 left shoes be called L and the 3 right shoes be R. So we see that there are only 8 possible combinations of L's and R's, or I guess permutations, that we can have in order to satisfy this condition. So these 8 possibilities are L, 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 R, 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 and we can flip that to get R, R, L, R, 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 L, 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 and then L, R, 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 L, L, R, L, 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 R, L, L, R, R, L, R, R, L, 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 R, and finally we have L, R, R, L, L, R, and R, L, L, R. So these are our 8 cases, and we can count how many possible ways to order the left and right shoes within them to have our final answer. So for the first 2 cases, L, 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 R, 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 and R, 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 L, 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 we see that there are 3 factorial, which is 6 ways to order the left shoes. And then after we do that, the right shoe that's next to the left shoe is predetermined. So we can have 2 factorial ways to order the remaining 2 right shoes. So this is 3 factorial times 2 factorial, which is 12. So each has 12 ways. Okay, so for the next case, there are again 3 factorial ways to order the left shoes. And then you see that because there are 2 right shoes next to left shoes, they are both predetermined by the left shoes. So now all 3 right shoes are in order already. So there are only 6 cases. And the same applies to the next 2 cases. They all have 6 each. And this is because there are 2 left shoes next to right shoes. So in total, this is 12 plus 6 plus 6 plus 6, which is 18, plus 12, which is 30. And then we're multiplying that by 2 because it's 12 each, 6 each, 6 each, and 6 each. So our final answer will be 30 times 2, which is 60, which is A. Okay. Moving on to question 21. So 2 straight pipes with radii 1¼ lie parallel and in contact on a flat floor. The figure below shows a head-on view. What is the sum of the possible radii of a third parallel pipe lying on the same floor and in contact with both? So we are given these 2 circles right now, and our third one can either be down here or somewhere over here, where we assume that this circle is tangent to the line and the 2 circles that we're already given, which I guess it would look like that. So we see that if we let's just consider the smaller case first. So if we let this and this be the radii, so if we connect them, then we can see that this is 1, this is 1/4, and this is R, right? So square root of, we can also connect this to this. And then we can use Pythagorean for every length. So we can set variables, I guess. So A, B, C, O, P, and Q. So AB is equal to 1 minus R squared plus, actually, no. It would be 1, if we draw this line over here, 1 plus r squared minus 1 minus r squared. And then the square root of that. And then BC similarly would be 1/4 plus r squared minus 1/4 minus r squared. And then AC would be the square root of 1 plus 1/4 squared minus 1 minus 1/4 squared. And then we can solve for r because AB plus BC is equal to AC. So then we see that in this case, r will be equal to 1/9. And then we can basically do the same thing for the other case where the new circle is bigger than the other two, because we see that the lengths are still gonna add to another length that we can find using Pythagorean. So after that, the r's will be 1/9 and 1. So the sum of the radii of the third parallel pipe is 10/9, which is C. Okay. Question 22. A group of 16 people will be partitioned into 4 indistinguishable 4-person committees. Each committee will have 1 chairperson and 1 secretary. The number of different ways to make these assignments can be written as this. What is R? So we have 4 4-person committees. So in order to do this, this is 16 choose 4 times 12 choose 4 times 8 choose 4 times 4 choose 4. And then we divide this by 4 factorial for order because they are indistinguishable. So this is the number of ways to pick the 4 committees. And now each has 1 chairperson and 1 secretary. So out of a 4-person committee, there are 4 times 3, which is 12 ways to choose these 2 people. So this is times 12 to the 4. And this will be written as 3 to the r times m. So we can find out how many factors of 3 there are. And basically we see that there are, so we can write this all out. This is 24, and then the top is 16 times 15 times 14 times 13 times all the way to 1, which is 16 factorial, divided by 4 factorial to the power of 5 times 12 to the 4. So r in this case, in the top there are 6 factors of 3. In the bottom, so 4 factorial, there are 5 factors of 3. And then in 12 to the 4, there are 4 factors of 3. So then r will be equal to 6 minus 5 plus 4, which is 1 plus 4, which is 5. So if we write that out, this has 6, this has 5, and this has 4. So r will be equal to 5, which is A. Okay. Next question, question 23. The question says the Fibonacci numbers are defined by f1 is equal to 1, f2 is equal to 1, and fn is equal to fn minus 1 plus fn minus 2 for n is greater than or equal to 3. What is the value of whatever that is? So you see that this is basically the Lucas numbers, which is essentially the Fibonacci sequence, but you start with the numbers 2 and 1. So the next numbers are 3, 4, 7, 11, etc. So over here, f2 over f1 is equal to 1. f4 over f2 is equal to 3. f6 over f3 is equal to 4. And then you just keep on going. So the value of this is the sum of 1 plus 3 plus 4 plus 7 plus 11 plus 18 plus 29, 1, 2, 3, 4, 5, 6, 7, plus 47 plus 76 plus 123, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is this is 10 Lucas numbers. So when you add these up, you see that the answer is 320, which is 319, which is B. Another thing that you could do for this question is just bashing it out, which is what I did when I first saw it. So you basically just find all of the first 20 Fibonacci numbers, and then you calculate their quotients. So yeah, that could work too. Okay, question 24. Let P of m be equal to m over 2 plus m squared over 4 plus m to the 4 over 8 plus m to the 8 over 8. How many of those values are integers? So what you see is that if m is even, then P of m is going to be an integer, because like you can write m as 2n, right? So P of m would be n plus n squared plus 2 times n to the 4 plus 32 n to the 8. And because n is an integer, we know that P of m will be an integer if m is even. So P 2022 and P 2024 are integers. So now we have to consider the cases where m is odd. So we see that m can be written as 2n plus 1. So the first fraction will be an integer plus 1 over 2. The second will be an integer plus 1 over 4. The third will be an integer plus 1 over 8. And the fourth will be an integer plus 1 over 8. So if you add this, then this becomes 1, which is still an integer. So that means that P of an odd number will still be an integer. So that means that 2023 and 2025 both work. So we see that there are 4 values that are integers out of the 4. So our answer is E. Okay, and last question, question 25. Each of 27 bricks has dimensions A times B times C. These bricks are arranged to form a 3x3x3 block. A 28th brick with the same dimensions is introduced, and these bricks are configured into a 2x2x7 block. The new block is 1 unit taller, 1 unit wider, and 1 unit deeper than the old one. What is A plus B plus C? So basically what you see is that what they're giving you is 3c plus 1 is equal to 7a, which is this and this. And then 3a plus 1 is equal to 2b, which is this and this. And finally, 3b plus 1 is equal to 2c. After you get these 3 equations, you can solve for a, b, and c. So consider the last equation. So c is equal to 3b plus 1 over 2. So we can sub this into the first equation to see that 9b plus 3 over 2 plus 1 is equal to 7a. So this is the same as 9b plus 5 is equal to 14a. And we also have that 3a plus 1 is equal to 2b. So we can solve this system of equations. So we can multiply the first one by 3, so 27b plus 15 is equal to 42a. And for the second one, we can multiply it by 14, so 42a plus 14 is equal to 28b. So now we can substitute 27b plus 15 for 42a. So this becomes 27b plus 15 plus 14, which is 29, is equal to 28b. So then b is equal to 29. And now we can solve for a and c. So C is 3b plus 1 over 2, which is 87 plus 1 over 2, which is 44. And A is equal to 3c plus 1 divided by 7, which is 133 over 7, which is 19. So if we add these up, then 29 plus 19 plus 44 will be equal to 92. So our answer for question 25 is E.
That wraps up Kaylin's full solve of the 2024 AMC 10B. Thanks so much for watching and supporting Math Together Canada. Don't forget to like, subscribe, and comment your favorite question. We'll see you next time!